So the first thing I'm going to do is I'm going to draw these processes, right? So it starts at 175 pascals in a volume of 1.6. So here's our volume, right? 175 would be right about there, right? And it's an isobaric compression to 0.4. So there's our 0.4. So let's see if I can, I'm going to see if I can draw a nice straight line there. See if you can too. That's amazing. Look how good I am. Isn't that amazing? That is a good straight line. So this is process number 1, right? And then it's isochoric cooling to 50 pascals. So here's 50 pascals, right? So let's see if I can do that. Again, I'm going to try my very best to draw a straight line. Here goes. Ooh, that is really good. You got to admit that I'm pretty good. That's process 2, right? Now let's see, isobaric expansions. So we're going to go back out to here. They're all rectangles, by the way. Oops, that's not quite as good as... There we go. And then isochoric heating back up to return back to there, right? So this is process 2. This is process 3, right? And then it says find the highest and lowest temperature. I'll give you this clue. This will be our lowest temperature. That'll be our highest. So the farthest you are from 0, 0, that would be absolute 0 there, right? The closer you are, the colder you are, and the farther you are, the hotter you are. So that's the point that's the farthest from that. Okay, so let's find these things here. So let's remember that we've got the moles here. So for all of these, N is equal to 0.280, and then PV equals nRT, right? So T is going to just be PV over nR, right? So the temperature here, for example, the temperature, I'll call that, I don't know, I'll call that point A, right? The temperature of A is going to be the pressure, which is only 175 pascals, right? This is truly an ideal gas because that's not very much pressure. Times 1.6 cubic meters, right? That's our volume divided by 0.28 times 8.31 is our R. Okay, let's see. And this, by the way, is going to be, this is as units of joules per mole Kelvin, right? And then this numerator has the units of joules, this has units of moles, so you end up with 1 over kelvins, which is just what we want. We want kelvins. So 175 times 1.6 divided by 0.28 divided by 8.31. And that is 120.3. So that's 120.3 kelvins, right? And then this temperature, I'll call this A, B, I'll call this C. The temperature at C is, again, PV over nR, right? From the ideal gas law, so we're just using this, right? So anytime you know the moles and you know a place on a PV diagram, you can find the temperature. It corresponds, every different spot. Now there's many spots of the same temperature, right? But every spot has a particular temperature. Okay, it's supposed to be an N. All right, so there we go. So this pressure here is, what is it, 50 pascals? Right, and then that volume is 0.4, and then divided by 0.28 times 8.31. So 50 times 0.4 divided by 0.28 divided by 8.31. And that temperature is 8.6 kelvins. That's awfully chilly. Okay. And again, we can find any temperature we want. If you freeze, if you have a brain freeze and you can't remember which one's the highest, which one's the lowest, just find the temperature of all of them and then, you know, hey, that's pretty good. All right, so let's see. I think we've done everything. Yeah, there we go. We did everything.